Okay, so the idea of atoms and molecules came from the Greeks, and there was this guy named Democritus, and Democritus said that we could break down all matter into these small little tiny bits if we kept cutting it, and he coined that term atomos, which means to be uncuttable or undivisible. Now, on the large scale, elements, compounds, all have different states of matter, and so states of matter are linked to the kinetic energy of a molecule. And so if we look right here, the ones that you're probably familiar with are going to be solids, and so we could think of this right now as like ice in this beaker. As we start to add energy to it, those water molecules will actually move around, and so that forms that next state, which is going to be called a liquid. And if we give enough energy to it, then this is going to be water boiling, or these elements are boiling, and so they're eventually jumping off into a gas. And so you're probably familiar with those three. So if we decrease the energy, then we can go right back to a solid. Now the two ones on here that I think are pretty cool are plasma. That's when we get a gas really excited and it starts to ionize, so it starts to give off electrons. Then we form something called a plasma. Where have you seen a plasma before? You'd see that like in stars, but you also see it like in fluorescent lights. So that's a state of matter that you're maybe familiar with. But what happens when we really cool it down? When we really cool it down below a solid, we form something called Bose-Einstein, let me try that again, condensate. And so it was predicted by these two scientists, Bose, who was Indian if I remember, and then Einstein, who was German. And what they predicted is that when you really cool stuff down towards near absolute zero, weird stuff is going to take over. And so this really wasn't tested until 1995, when a couple of scientists at the University of Colorado actually were able to use lasers to cool stuff down toward near absolute zero. And what they found is that when you cool it down, the Heisenberg uncertainty principle takes over. And what does that mean? Well, when you slow down those atoms, you know specifically where they are. And according to Heisenberg's uncertainty principle, when you know something is, where it is, you don't know anything about its momentum. So you get this weird spike where you don't even know where the atoms are. And that's pretty wild, and that's quantum theory. But again, there are 5 states of matter. Going from energy, we go from plasma, which has high energy, all the way down to this Bose-Einstein condensate. But movement between those, we've got terms for those. So what happens if we take a gas and turn it to a liquid? You're pretty familiar with that. We call that condensation. Whereas likewise, if we vaporize, it moves up to gas. And so I love this diagram here because it shows all of those. But remember, as we increase the energy, then we're going to move up into different states of matter. How do we measure matter? We could measure it directly, and so we could put it in, for example, a graduated cylinder, and this is the meniscus, and you measure it along that point. We could actually calculate it using volume, or we could use displacement, where you measure the amount of water, you put an object inside it, and then we measure how much it displaces the water. So we could measure directly matter, but also remember that we can measure it indirectly. How do we do that? Imagine if I take a cup of the earth, and let's say that the earth was homogeneous. If I take a small portion of the earth and figure out the mass of that in grams for a specific volume, I could then, let me scratch that, if I take the mass of a small bit and the volume of that, that's going to equal the mass of a large volume. And so, for example, if I have a small volume, we'll call that mass 1 and volume 1, and I want to figure out how much the earth weighs, all I have to know is the volume of the earth, and then I can use the factor label method to figure out the mass of the earth. And so sometimes in science we can't measure really large things and really small things. And so instead of measuring it directly using a scale or a graduated cylinder, we actually have to resort to math. And we use ratios to figure out how much it weighs or how big it is. And so I think that's it. Where do we find matter? And we'll do this in the next few podcasts. We find it on the periodic table. And so the periodic table organizes all of those pure substance elements that we have into an organizational chart that also shows us properties of the matter. And so that's just kind of an introduction to matter, and I hope that's helpful.